Hi there, my name's Thorsten Sideboard and I'd like to give a demonstration of software I've been working on. It's called Soundboard or SBShell, Soundboard Shell. It's a command line music making environment inspired by a Unix shell. Unix shell is your shell to the operating system. It's how you deal with the operating system. You ask it to do things and you can run and manage processes. Here, the metaphor, rather than an operating system, you're running a music operating system, a mixing desk basically that has access to multiple instruments which you can create and control through a programming language called slang. I've been writing quite extensive documentation for it and a user guide, all of which you can find at the website sbshell.com or on my GitHub or Codeberg, where there's mirrored repository on both of them. There's an install script for installing all your dependencies, which on my testing seems to work pretty well. It should get you most of the way there, if not completely there, and it'll get you going on Linux and OS X. And I mostly work on OS X, so it's definitely more stable and tested there, but I do have it working on my Linux desktop downstairs as well. Once you've installed the dependencies, you launch it from the command line just by the SBShell command. It takes you into your interactive REPL with your header, and the first command you should know is PS, which is your program status. Tells you everything that's going on. It tells you what the mixer is up to, which is some various global variables here. Volume set to maximum, BPM set to 140. Loop length, we'll get more into that. Basically the lingua franca of Soundboard is MIDI ticks, and of which there are 3,840 MIDI ticks per loop. So no matter what your BPM is set to, you can always guarantee that the actual MIDI loop length will be the same. So you can, rather than like dealing with milliseconds or such, if you actually change the time, as long as you're dealing with MIDI ticks, it should always stay in sync. MIDI device, you can attach MIDI keyboard, WebSocket. I also have a JavaScript EQ, so if I actually want to see stuff, I can sort of send the data via WebSocket to JavaScript. The mixer has a couple of sends. It's got a delay, reverb, and distortion, and you can send groups of these sound generators all there. And the mixer also has a crossfader. You can assign your sound generators there. Here are all the variables that's been created. And so variables can be standard integers, strings, booleans, arrays, hash maps. But in addition, what makes Soundboard different is that you can also create sound generator types, of which there are 5. There's sample or one-shots. So this is my sort of default desktop. So I've already got like a drum kit loaded of individual ones. I have 3 instances of my FM synth, which is based on a DX100. We'll get into detail of all of them, but the FM synth is based upon a DX100. It's a 4-operator FM synthesis. You can change this as your kind of voicing section, your kind of the globals for the actual synth itself, and there's the 4 operators which can change their envelopes, their the actual oscillator wave type and such. There's 4 LFOs which can route to various destinations. And there's in the voice selection here, this is how you kind of configure FM synthesis. The algorithm refers to how these operators are connected, whether they're connected in a series, meaning operator 4 would oscillate 3, which would oscillate 2, and you can combine them in various ways. These are the standard DX100 FM synth algorithms. Just for reference, you can just type it here, and I've got an ASCII version of it. So algorithm 0 basically was the one I described there, where operator 4 oscillates 3, which oscillates 2, which oscillates 1. Algorithm 1 3 and 4 both oscillate 2, which you can see them yourself, getting right up to algorithm 7, where the 4 oscillators are sent to the output. So it's basically additive synth at that point. We have the four oscillators, their signal is combined to give you the output signal. So in my setup I have 3 instances of the FM synth. I have an instance of a mini synth. Well, let me show you it first. Standard subtractive synthesis. It's got 4 oscillators. Your first 2 are mostly in tune unless you set detune them, but this is where your frequency is set to. Oscillator 3 is usually, it's like set 1 octave lower to give you your low end, and oscillator 4 is set to noise to give you some noise. Again, we've got some global settings here for whether it's set to mono mode, hard sync, detune, legato, standard synthesis things. And we have 2 LFOs, 1 LFO, 2 LFO, 1 envelope, and 2 envelope. And these enable, you can basically send your LFO or your envelope generator to any of the targets. So send it to the filter Q, to the oscillator frequency, panning, amplitude, and pulse width. And we have the drum machines. For the drum machine, the MIDI numbers are slightly different. It only basically plays the first 8 MIDI notes, and they get mapped into whether it's a bass drum, snare drum, etc. Which is kind of fun. You can do a lot just with the fact of them. So for instance, one of the built-in functions, you can create a random array of any length. You specify your length and which numbers start and finish. So we could do 0 and 1, which could be sent to let's say the bass drum. This is one of the samples. If we change that to 8, all those mappings would then be sent to the SB drum, and we can get something. You may be wondering how I know a lot of these MIDI numbers. So there's built-in reference here, and you can see all your MIDI numbers, and I have a lot of functions which are helpful for thinking that way. So for instance, notes in key. If you wanted to find out the MIDI notes for being in a key of C, we can look it up here. So it's 36 would be middle C. And so we get 36, 38, 40, 41. You see, there's also, just in case you do want to check, it will give you an output in text just so you can verify if I haven't made mistakes. There's also key modifiers which are listed here. So without any modifier, we get just a natural key. Natural minor, we can adjust notes in key. So you get minor key, minor C. We have harmonic minor, melodic minor, and Phrygian. I found that one online. I don't think I've actually used it. And from there as well, there's other notes in chord. So for instance, if you wanted a D chord, you also have to give that the key that you're in. So if you were in the key of C, again, you can add a key modifier. However, I think actually the first modifier after this is whether I want a chord modification. So if I wanted a 7th, I then get the 4 notes, 7th inversion. So it's the same, but it's if you notice that the last one, the 7th itself is brought down an octave. And again, even with these ones, you can then add another modifier to get the key. Because if, for instance, we were in that minor key, let's see how this sounds. Cool. So that's mini synth, DX synth, oneshots, the drum synth, and so there's a granular synth as well. Let's assign that to a variable and create a looper. You can also treat it rhythmically, so you could actually send for instance, that random array. So we can change lots of things. You can change the pitch, the length, you can change all these granular things like grains per second, quasi-grain fudge, which is how accurate it is. There's a grain spray, which again is rather than just sticking to where you are in the index, it would sort of randomize where it's going to pick up things from. The attack, decay, release are more for when you're doing note on, note off. And there's a schedule thing as well, so we can actually bring the volume up. Schedule it for now, go from 0 to 1 over 3840 MIDI ticks, and we will set volume synchro to the variable. We can send to the delay. It should fade out eventually. So that's the kind of basics of how you enter the environment, what you can do with all the instruments themselves. But of course it's kind of harder just to operate directly from typing in specific note on, note off. So one of the things I've been working on is that you can actually live code. You can create, let me get a shorter one to show first. You can create these objects called computations, and they're structured very much like Arduino or P5, and by that I mean the actual object has two functions within it. So it has a setup function. So when you create this, the setup is like the environment for this computation. So in this setup I have a couple of different patterns which I'm going to use for drum loops. I have some offsets and velocities, and once that environment's set up, every time you run the computation it will actually call the run function. And so for here it sets, initially it will set the drum pattern to the first of these patterns, but if count is 2 or 17 it will basically switch through changing your drum pattern to a specific one. And we'll walk through, we'll step through 16, check if the pattern is set to 1, and it will do a note on for the drum. So let me show that off. So that was when I imported it, it basically runs everything in init. So it loads in a number of different samples. Lots of things you only want, they're not idempotent, you don't want to run them each time, such as setting pitch and adding effects. Just this is so we can do live code, and then without having to keep, you don't want it to keep adding delay every time you save the file, for example. So now that I've imported that, all these functions and instruments are now available within my environment. This function is in the environment, so now if I run it, it will basically call the run function. And so you can basically live code with all these functions, so you can kind of create them off. But what you can do with these so they continue to run is you assign them to a process slot. So I could do P1. And so at the top of every bar, these processes, the run function will be called, and this is a very common pattern. So like specifically for 16s, I will schedule ahead. I showed you note on, but you can do note on at, and the third parameter for that takes a specific value in MIDI tick, so it will play it in the future. So 16 times the PP, which we showed you there, which is actually 3840 divided by 16. So that's basically how you play those patterns across time, and we have an offset for each one, the velocity changes, and the offset increments each time, and the velocity index increments each time. What's another? Let's oh, did I close that? Where'd that go? There it is. So you can basically kind of keep adding up more and more things. And for a long time actually I worked this way, and I basically have my functions which could switch on and off just manually. Take out my drums, a breakdown. Which is good for live performance, but if you're actually trying to record something, it's hard to get it exact each time. But I realised because functions accept other functions and can do all sorts, I can basically just create one computation, which is my arrangement, and it has a local variable count here. So the first time it runs, it will run these on they will keep going, and then 4 bars later it will call in some others. Let me demonstrate that. And I'm basically going to make it process 99 just so I don't overwrite it, which I'd often do. I would assign this to process 1 and then within here it would then overwrite itself by another process. So you get the idea. I won't play the whole track. I just leave KRS-One chatting in the background. Cool. I think that's probably enough for like a demo. I think that's 20 minutes already. So that gives you a walkthrough. As I said, check out the website, check out the GitHub or the Codeberg, find the user guide. And the user guide is, I've kind of tried to walk through some of it here. The user guide's in much more detail, so you can take time and go over all of these. And yeah, I would love to hear what someone else can come up with for this software. So if you make something with it or have any issues, get in contact. Thorsten Sideboard. Thanks so much.